everyone, my name is Marie from Bachelor of Science in Information Technology.
Hi, I'm Jeremiah Kabatu from Bachelor of Science Information Technology.
Good day everyone, I am Jandoy De Ramirez from College of Computer Studies.
My name is Anthony Kotawi.
Hello everyone, I am Jimlot.
Hi, my name is John Paul Gutierrez. My friends call me JP. I'm a student from BUN Pitayug under the course BSIT.
Hi, I am Francine George G. Amelio from BSIT.
Hi, I am Francisco V. Villanueva Jr. from College of Computer Studies.
Hello everyone, my name is Mar from the College of Computer Studies.
Hi, I'm Jasmine Galising from BSIT.
Hello everyone, I am Macraven Angelo T. Johnson from College of Computer Studies.
Hi everyone, I'm Jumel Labeda from College of Computer Studies.
Hi, I'm Delbert Carlos Cunanan from BSIT 1.
Hello everyone, my name is April Rose B. Olipas from BSIT 1.
Hello everyone, I'm Arsenio Tisiban Jr. from Computer Studies.
Hi guys, my name is Manolito de la Cruz Jr. from Computer College of Studies.
Hi, I'm Lawrence Abigail Escalivo from BSIT 1.
Hello guys, I'm Felix Andre Camarillo, BSIT 1.
Hi everyone, I'm Crystal Jane De Peralta from BSIT 1.
Hi everyone, my name is Shunai Jade Sinibago from the Department of Computer Studies.
And today, we are going to talk about mathematics in the modern world.
First, we are going to talk about patterns. Do you know what patterns mean? According to study.com, a pattern constitutes a set of numbers or objects that are related to each other by a specific role. A pattern is also known as the sequence, and there is a finite or infinite number of numbers that make up a single pattern or a single sequence. Felix will now continue this topic.
Thank you, Lloyd. Now, if you haven't noticed this before, everything you see around us are made up of different forms of designs that are repeating is what we call patterns. For example, your tiles on the floor, the patterns of the leaves, the waves of the roofs, the design of your clothes, and more. Let me show you some examples and Anthony will explain further.
Now that you've seen the patterns that we showed earlier, you're probably wondering, why are patterns related to mathematics? Well, it is because patterns are sequences that repeat according to a specific role, and this specific role is actually mathematical role. That is a segue in practicing and dealing with mathematics, that we deal and associate ourselves because math is everywhere and around us every single day.
We hope you learned a thing or two about patterns. And if you want to know about patterns, the next part is the Fibonacci sequence that will be taught to you by Francine.
Hello, we are going to talk about the Fibonacci sequence. Did you know that Fibonacci sequence is actually one of the famous formulas in mathematics? It is because it is a set of numbers that starts with 1 or 0. And it goes like this: 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on.
In order to get the Fibonacci sequence, you need to get the sum of the preceding two numbers before Anthony explains who Leonardo Fibonacci is.
Thank you, Francisco. Now I will explain who Leonardo Fibonacci is. Well, He was born in the year 1170 in Italy, and he is one of the most famous Italian mathematicians and a number theorist. He introduced the world with such wide-ranging mathematical concepts and what is known as the Arabic numbering system, the concept of square root, but most importantly, he invented the Fibonacci numbers and the Fibonacci sequence. And we will show some examples of the Fibonacci sequence in real life. We have here Manolito and Jasmine to fill you up with more details about Fibonacci sequence, but before that, we will show you some examples.
There is a resemblance of Fibonacci sequence in leaves because there are 8 leaves in one stem, and also there is Fibonacci sequence in flowers because it has 5 petals and lastly. Calamansi has also Fibonacci sequence because there is 5 pits or seed inside the calamansi.
On the conclusion, it shows that Fibonacci is part of our everyday lives. Based on the example shown earlier, there is always Fibonacci sequence in everything. Now, we will move on to the best for last of this vlog, golden ratio. It will be taught to you by Lawrence Abigail.
Lastly, but not the least, we will be taking about the topic called golden ratio. Let's get into it. Golden ratio is also called as golden section, golden mean, and lastly, divine proportion. Did you know the golden ratio as approximation of equal to 1.6? So the ratio is 1 to 1.6 when the line segment is cut into 2 pieces in different lengths.
The ratio of a whole segment that divided into a longer segment and into a shorter segment. The golden ratio is also the heart of the many of the proportions of the human body. John Paul will now show you something that you can take part in. Take it away.
Thank you, Delbert. Now let's do a small exercise and I want you to join in. Hold out your arm like this in the video shown. Look at the distance between your shoulder to your elbow. And now your elbow to your fingertips. Now the distance between your shoulder to your elbow is 1. The distance between your elbow to your fingertips is 1.6. But there's more than that. So we'll look further. Look what comes next. The distance between your fingertips to your wrist is also 1. And the distance from your wrist to your elbow is 1.6. Let's keep going. Look at the furthest tip of your fingertip up to the bottom of your finger is 1. And the bottom of your finger to your wrist is 1.6. Now, the line segment of a golden ratio is that.
The fact that our bodies are perfect samples and complements the golden ratio is amazing. Now, Gray, will you take on how structural designs also use golden ratio?
Thank you, Jeremiah, for the introduction. Now, we will show you some examples of structures that use the golden ratio as their base. Let's take a look. This is the Great Sphinx in Egypt, Notre Dame in Paris, the Taj Mahal in India, and lastly, the Parthenon in Greece.
That's all for the golden ratio. I hope you learned something along the way while you watch this video. Remember, golden ratio is approximately equal to 1.6. It is the ratio of the line segment that is cut into 2 pieces of 2 different lengths. Thank you for watching. Before ending this video, we will show you some trivia led to you by the rest of our group.
Did you know that the Fibonacci contributed to the spread of decimal numbers? Fibonacci helps spread the as of decimal numerals. Because of these people called him the most talented Western mathematician of the Middle Ages.
Did you know that the Fibonacci sequence is also used in music? Wolfgang Amadeus Mozart executed the Fibonacci sequence in his piece of music. A good example of that, the Mozart Sonata 279, he in fact wrote the mathematical sequence in the margin of his sheet music.
Adding on what Epler said, Literalus, who is made by Tool, also incorporated the Fibonacci sequence in his lyrics. Take a listen and count the syllables. Do you know that the golden ratio is also known as the golden section, median section, golden proportion, divine section extreme and mean ratio, and golden mean? It is also known as a sextio aurea in Latin.
Did you know that November 23 is actually called Fibonacci Day? It is because of corresponds to the first four numbers of Fibonacci sequence, which are 1, 1, 2, and 3.
Did you know that brands use golden ratio to create their logos? A good example is when Pepsi paid several $100 million to create their logo in 2008.
Did you know that the value of the golden ratio is not easily written as a fraction? Because it is a continued fraction. And it is therefore usually written in a shortened decimal number. Or as the symbol P, this is what P looks like. That's P right there.